In this video, we will present the midterm status of the assembly knowledge store. In current practice, discrete manufacturing companies use numerous heterogeneous data sources to store assembly information. When specific information must be retrieved, for example, for answering operator questions through the digital assistant, multiple data sources must be consulted and combined. Another challenge is that these data sources may use different technologies and semantic data models. Typically, a data access layer is configured per data source. This requires specific programming skills and is time-consuming in setup and maintenance. We add the assembly knowledge store as a function block to the digital assistant to overcome these problems. First, we developed the assembly information domain ontology, which contains the main structure and vocabulary for integrating and linking assembly information from different data sources. Next, we use a standardized mapping language to map the original data source to the defined assembly information ontology. In this way, multiple data sources can be represented as a graph structure, thus as nodes and edges. We can now query all mapped data sources via a single endpoint using a graph query language. These principles lower de-integration effort because defining the data source mappings is the only manual action required. From an application point of view, only one semantic model must be used: the assembly information domain. Nevertheless, the shop floor operator won't explore and query the assembly knowledge store directly, but instead ask a question and subsequently receive human-readable answers via interaction with the digital assistant. We created a question and answer domain to map these questions and answers to assembly information and contextualize them. The assembly reasoning engine will mainly use this domain to estimate the relevant questions and process questions to obtain accurate answers. The conversational history between the operator and digital assistant is stored in the assembly knowledge store, along with the conversation context and operator ratings. This information is a feedback loop to the assembly reasoning engine to further optimize the internal probabilistic model. Finally, maintainability is an essential aspect of the assembly knowledge store. To ensure high-quality question answering and to facilitate the maintenance of the assembly knowledge store, data quality problems and potential mismatches between data sources must be identified. To do so, we use semantic rules to flag information that might need attention and to fill in missing connections. By introducing the assembly knowledge store, we already see a reduced configuration time to integrate manufacturing data sources. Nevertheless, configuring the system for a high-quality digital assistant still requires much effort. In the next steps, we will further develop the question-answer domain towards generic question templates and further facilitate the assembly knowledge store maintenance through semantic rules.